Product of power states that if n and m are positive integers, then a to the power of n times a to the power of m is equal to a to the power of n plus m. Okay, let's have some examples. For example, if we're going to have here x squared times x cubed. So the result here will be you're going to copy the base x, then add the exponents 2 plus 3. So 2 plus 3 is 5. So you're going to have x to the power of 5. Another example, let's have b cubed times b to the power of 4. So this is equal to, copy the base b, then add the exponents 3 plus 4. So 3 plus 4 is 7, so we're going to have b to the power of 7. Another example, let's have y to the power of 5 times y to the power of 6. So this will be y, the base, then 5 plus 6. So 5 plus 6 is 11. So you're going to have your answer as y to the power of 11. Okay, last example. Let's have a to the power of 14 times a. So in here, we're going to copy the base a. Then if the variable has no exponent, it means that it is 1. So a here, the exponent will be 1. So you're going to have 14 plus 1. So 14 plus 1 is 15. So your answer will be a to the power of 15. Power of a power states that if n and m are positive integers, then a to the power of n raised to the power of m is equal to a to the power of n times m. Now in here, if we're going to have examples, example number 1, let's have x cubed raised to the power of 4. So what you're going to do is you're going to copy the base x, then multiply the exponents. 3 times 4, then 3 times 4, that will be equivalent to 12. So your answer will be x to the power of 12. Example number 2. If we're going to have y squared raised to the power of 5, that will be y raised to the power of 2 times 5. 2 times 5 is 10, so our answer will be y to the power of 10. Example number 3. A to the power of 4 raised to the power of 6. So that will be, you're going to copy the base a, then multiply the exponents. 4 times 6. So 4 times 6 will be 24. So a to the power of 24. Okay, let's have our last example. Let's have b cubed raised to the power of 10. So copy the base b, then multiply the exponents. 3 times 10. So this is b. 3 times 10 is 30. So b to the power of 30. Power of a product states that if n is a positive integer, then a times b raised to the power of n will be equal to a to the power of n times b to the power of n. So in here, we'll just raise each of the factors to the same power, which is n. Let's have some examples. Example number 1. Let's have x, y cubed. So x, y raised to the power of 3, that will be equivalent to x cubed, then times y cubed. Number 2. Let's have a, b, c raised to the power of 4, and this will be equivalent to a to the power of 4, b to the power of 4, c to the power of 4. So in here we are raising each of the factors a, b, and c to the power of 4. Number 3. Let's have 2ab raised to the power of 5. So this will be equal to 2 to the power of 5, then a to the power of 5, and b to the power of 5. 2 to the power of 5 is 2 times 2 times 2 times 2 times 2. So the answer here will be 32. So 32, a to the power of 5, b to the power of 5. Okay, let's have our last example. Let's have negative 5x y then squared. So we're going to have here negative 5 squared and x squared then y squared. So negative 5 squared, negative 5 times negative 5 is 25. Then just copy x squared then y squared. Power of a fraction. A over b raised to the power of m is equivalent to a to the power of m over b to the power of m, where b is not equal to 0. Now in here, we will just raise the numerator and denominator to the same power. So we're going to have a, the numerator, raised to the power of m, and b, the denominator, raised to the power of m. Okay, let's have some examples. Number 1. Let's have a over b raised to the power of 4. So the result here will be a to the power of 4 over b to the power of 4. Another example, let's have 1/2 squared. So 1/2 squared, that will be 1 squared over 2 squared. 1 squared is 1, then 2 squared is 4. So your answer will be 1/4. Let's have 2 over 3 raised to the power of 4. So this will be equivalent to 2 to the power of 4 over 3 to the power of 4. So 2 to the power of 4, it's 2 times 2 times 2 times 2. It is equivalent to 16. And 3 to the power of 4, 3 squared is 9. So we're going to have here 9 times 9. So 3 to the power of 4 is 81. Okay, last example. Let's have x over y raised to the power of 10. So the answer here will be x to the power of 10 over y to the power of 10. Quotient of power states that if a is an element in real numbers and a here is not equal to 0, and n and m are positive integers, then a to the power of n divided by a to the power of m. We have here 3 cases. First, that will be equal to a to the power of n minus m if n is larger than m, meaning the exponent of the numerator is larger than the exponent of the denominator. Another case is 1 over a to the power of m minus n, that is if m is larger than m, or the exponent of the denominator is larger than the exponent of the numerator. And last will be that is equivalent to 1 if m is equal to n. Let's have some examples. Let's have 5 to the power of 8 divided by 5 to the power of 6. So in here, the exponent of the numerator is larger than the denominator, therefore we can use the first case. We're going to copy the base 5, then we're going to subtract the exponent of the numerator, which is 8, and the exponent of denominator, which is 6. So the answer here will be 5 to the power of 8 minus 6, that will be 2. So 5 squared, which is equivalent to 25. Another example, let's have d to the power of 7 divided by d squared. So we're going to copy the base d, then subtract, the same with number 1, subtract the exponents, 7 minus 2. So 7 minus 2 is equivalent to 5. So we're going to have d to the power of 5. Okay, example number 3. Let's have a to the power of 5 over a to the power of 7. Now in here, the exponent of the denominator is larger than the exponent of the numerator. So we're going to use the second case. We're going to subtract the exponent of the denominator to the exponent of the numerator. So we're going to copy 1 over the base, which is a, then subtract the exponent of the denominator, which is 7, and the exponent of the numerator, which is 5. So this will be 1 over 7 minus 5 is 2. So this is equal to a squared. So the answer for number 3 is 1 over a squared. Number 4. Let's have c to the power of 4 divided by c to the power of 10. So again, this is applying case number 2. So we're going to have 1 as the numerator. Then we're going to have here c, the base. Then subtract 10 and 4. So 10 minus 4. So 1 over c power of 10 minus 4 is 6. So the answer will be 1 to the power over 1 over c to the power of 6. Number 5. Let's have x cubed over x cubed. So in here, the exponent of the numerator and the denominator is the same. So the answer here will be 1. Number 6. Another example, let's have 4 to the power of 5 over 4 to the power of 5. So the same with number 5, they have the same exponents. Therefore, we're going to have the answer as 1.